Welcome back to CircuitPython School with Prof G. Break out the electric bass and cue up the horns, because after we solve the SOS Morse Code challenge, we're going to bring on to func by learning functions in CircuitPython. Let's learn big. Now before we get to the challenge solution, I'm going to save the code from the last video. I should have done this at the end of the last video, so I'm going to double click on the tab up here that says code.py. I'm going to navigate to my desktop where I had my CircuitPython school folder, and I'm going to give it the name lesson-2-get-flashy, save that. Then I'll double click on the tab again and make sure that I've navigated to my CircuitPy folder, and I'll resave this as code.py so that any changes I make here are going to be saved to my CircuitPy device, my CPB, and so I'll see the result of any changes executing on the CPB. Now let's show the challenge solution. Now remember, we needed to get our CPB to flash SOS in Morse code. We had these rules for Morse code. Then we had a set of value names that I asked you to use for consistency so we could compare our code. These are the names that you see here. So let's head back to CircuitPython and start to enter these value names. First, I no longer need the flash time value here, so I'm going to delete that line. And I'm also going to change the comment at the top of my code so that it reads SOS Morse Code Challenge. Now underneath these two values for colors, I'm going to enter unit as equal to 0.2. That's 0.2 of a second, and you could put any value in here. Now I didn't give you a value to use for unit, but because of the way we're about to write our code, we can easily change this value, and that'll change the flash speed of our entire Morse code. Then I'm going to list out the names of the other variables I'm going to create. dit_pause, da_pause, between _dits _and _das, between _letters _pause, and between _words _pause. Now I've chosen to capitalize unit because it shouldn't change once it's been set. I certainly could have capitalized these other values, but since they're based off of the unit value, I chose to put them in lowercase snake case. By the way, when you work for an organization or contribute to an open source project, the projects that you work on will almost certainly have coding standards for you to follow that include things like how to name variables, functions, and other programming guidelines. But this will work fine for our example. Then using the rules that were stated in the challenge, we can show how each of these values is calculated. dit pause equals unit, da pause equals unit times 3, between dits and das equals unit, between letters pause equals unit times 3, and between words pause equals unit times 7. Now we're supposed to flash in the color red, so I'm going to add the color red under aqua as red equals, and in parentheses 25500. I'll delete the code under while true, and I'm going to enter some comments in here so that I know the code that I'm entering. So first I'll put in a comment for S, then I'll say comment period for dit, then I'm going to say pixels.fill in parentheses red to turn the lights red, then time.sleep passing in dit pause. That's how long to show a red light when you show a dit. Then I'll say pixels.fill black to turn off that dit, and below that I'll say time.sleep and in parentheses pass in between dits and das. Now before rendering the rest of my code, I figured I'd check my code right here, so I'm going to open the serial monitor, click on save, take a look at the CPB, and I have my 0.2 of a second dit flash over and over again in red, looking good. Now I'll close my serial monitor to give myself some more room, and this dit code that I've created here, well, I'm going to repeat that 2 more times for dit dit dit. I'm just going to want to change the sleep value on the last dit, so I'm going to highlight all of these lines here, starting with the comment dot, copy them, then paste them twice below the code that I've got. I'll adjust the indentation of these 2 comment lines so that they're flush with the rest of my code under while true, and I'm going to change the value that I'm passing into time.sleep for my last dit because I've just finished a letter, so what I should be passing in here is between _letters _pause. Now the code I've written for S is almost identical to the code that I need to write for O, so instead of typing code that's almost identical to the code above, I'm simply going to highlight all of the code below while true, copy it, and then paste it below the existing code. Then I can change the comment of the code that I just pasted in to read O, since I'm about to change this to represent the letter O. And then in the 3 areas where I have dit_pause in the code that I've just pasted in, I'm going to replace that with da_pause, and I've got my O code speedy quick. Now you do want to be very careful when copying and pasting code like this, but I know that the code is nearly identical, so I saved myself some time typing. Now we need another letter S at the end of this code. I've already entered the letter S, so I'm going to scroll up to the top, highlight and copy that code, paste it down below, and then the only thing that I need to change is the very last time.sleep. Instead of a between letters pause, I'm between words, so I'll delete that and enter between words pause. I'm going to open my serial monitor, and with my CPB on, take a look at that, save this, and would you look at that, I've got SOS flashing, challenge complete. And in fact, we can see the benefit of basing all of the values off of this unit constant that we created up top. I'm going to change that from 0.2 to 0.1, save, and we can see that our SOS is still readable. The ratios of the different values remain the same, but it's twice as fast. Well, now let's go beyond our challenge. If we wanted to add different colors, like say blue or green, first I'll go up here and under red, I'll add colors for blue and green. I'll write blue in all caps equals in parentheses 0, 0, 255, and green in all caps equals in parentheses 0, 255, 0. And now that I've done this, if I want to flash in blue instead of red, well, I could go down into my code and I can replace red with blue, but look, I've got to do that 9 times throughout my code. Well, there's a better way to write our code if we're not sure of the color that we want to use and we might want to change this. We can create an additional variable to hold our color, and then we just need to change the value in this additional value to change all of the places where we refer to that value. Now we are going to need to change every place where we refer to red, but what I'm going to do below the colors is I'm going to create a new value called light_color. I'm initially going to set that to blue. Then I'm going to highlight the name light color. I'm going to copy it, Command-C Mac, Control-C Windows. I'm going to paste it over blue, and I could paste it over all of the other instances of red, but Mu has a built-in find and replace feature. Now there aren't any menus in Mu, so you have to know about this in order to use it, but Command-F on the Mac or Control-F on Windows will bring up the find and replace dialog box. Now I've entered red in the find field, and in the replace field I've entered light_color, and I'm going to click on replace all, but this could be dangerous and I'll show you why. Now I really only want to replace the word red with the word light_color in this selection of code that exists in the while true block. Now Mu is a pretty basic editor. Most code editors, and by the way, programs that allow you to write code and provide debugging features and code completion and additional features, these are called IDEs for Integrated Development Environments. And most IDEs, like Xcode for building Mac and iOS apps or Visual Studio Code for Windows, they will allow you to make a selection and do a find and replace within that selection. But Mu unfortunately doesn't have that option, so it's replace all the values in the code or just one at a time. So if I've selected replace all and then I select OK in the find and replace box, this is going to replace every single instance in my code where red exists, and it's going to replace that with light_color, including the very first line where I define red as 25, 0, 0. Hey, I didn't want to change that value, so I'm going to go back and change this first line that mentions light_color to red. Now this should work, just be careful when you use find and replace. Now I can click on the Save button. I actually should have opened the serial console first, but I can see that the flashing SOS lights in red are now in blue. Now let's change this light color value to green and click Save again, and hey, the lights are green. And so now we see the real benefit of using an intermediate value like this. If you're not sure about the values inside of your program and you think that you might want to change them, using an intermediate variable will allow you to make the change once instead of having to make the change in lots of different locations. Now let's introduce functions in CircuitPython, and there's a reason why we want to use a function, because if we look at our code, we see lots of repeated lines. We see the same 3 lines that we use to produce a dit repeated 6 times, and we see the same 3 lines for does repeated 3 times. Now there's a principle in computing known as DRY, D-R-Y, for don't repeat yourself. Now frankly, in microcontroller programming, we're usually not as strict as we are in conventional programming because we often just want to get a quick program out and get it to work, and the programs usually aren't very big anyway. But there's no reason to take up all of this room with repeated code. We're going to get rid of this repeated code by using functions. Now functions are chunks of code that can be called repeatedly whenever we want to execute the lines of code that are inside of a function. So let's create a function for our dit. Now functions need to be created before they're called, and since we're going to use the function in our while true loop, let's create the function just above while true. And the first thing that we need to do is we need to define the function by giving it a name. So we do that by starting out with a def keyword to define the name of the function. Then we follow def and a space with the name of the function. Now most Python programmers will use lowercase snake case. Sometimes you'll see lower camel case for function names. We'll try to stick to lowercase snake case in our examples. So I'm going to name this function as lowercase dit, D-I-T. And we already know from some of the functions we've been using like print and sleep that functions always have parentheses following their name. And we need to include a set of parentheses here. Now at first we're not going to pass in any arguments between these parentheses, but we'll learn in just a bit how to create functions with arguments too. Now after the closing parentheses, we also enter a colon, just like we did when we set up our while true clause. And notice when we press return here, we indent below the function definition line. Now any lines that are after the function definition at this indentation level are going to be part of the function, and they're going to be executed whenever we call the function. and the function will be over when the first line is encountered that's at the same level as our function definition line or the while true line. Now, every time we want to create a dit, we execute these 3 lines here. So I'm going to highlight them along with the comment line, cut them out with a Command X on Mac, Control X on Windows. Then under my definition line for the dit function, I'm going to paste them in, Command V Mac, Control V on Windows. And now any place after this in my program where I want to call these 3 lines that are part of the dit function, I just have to type in the name dit followed by the open and close parenthesis. So right under the comment #S, I'm going to type in dit, and look what happens with code completion. Moo knows there's this new function named dit, so that shows up. I'll type my open and close parenthesis. Now I'm still going to keep this time sleep line here where I pause the amount of time that's between dits and das, but these 4 lines down here from 33 to 36 are lines that I've already got in my dit code, so I'm going to delete these and replace them with dit, open and close parentheses, keep the time sleep between dits and das below this, but then replace these other 4 lines again with the dit function call, open and close parens, and I'll keep the line below this time sleep with the between letters pause, but look what I've done. I've greatly reduced the number of lines in order to flash out the letter S. Now, it would be smart to open the serial monitor, then save and run the code now, but I'm going to live on the edge and feel confident in the code that I've just written. Feel free to test your code here and correct it if you've got any errors, but now what I want to do is offer a challenge to solidify what we've just learned. First, modify the code to call the dit function to create the last S in our SOS code, and then create a da function similar to the way that we created a dit function and call that to replace all of the code in the O part of our while true loop. Then run your code. You shouldn't notice anything different on your CPB, but you should see that we've written much more efficient code with far fewer lines. Well, the first part to replace the last S code with 3 calls to our dit function is super easy. I'm going to highlight these 5 lines of code that I've just written that have 3 calls to the dit function. I'm going to keep that last time sleep off. I'll copy this code, Command C Mac, Control C on Windows. Then I'm going to highlight all of this code that I used to create the second S, and I'll paste over this with the code that I just copied, Command V Mac, Control V Windows. But I'll keep this time sleep in here with the between word pause because now I'm pausing between words. And for the second part, we're going to create a function called da. So just underneath the dit function, but before while true, we'll type in def space da, D-A-H, open and close parenthesis, remember the colon. We'll press return, then we'll highlight these 3 lines that produce the da. We'll cut them out. We'll paste them inside of the newly defined da function. I'll fix the extra indent on the first line. Then we can go down here in line 45, and I can call da by simply typing in D-A-H, open and close parens. Then remember an O is 3 das, so I'm just going to highlight these 2 lines and paste them down below, so I have da, da, da. And I see as I narrate this video that I've got an extra time sleep dits and das in here, but I'll delete that later on in this video. So now let's open our serial monitor, and so that we can see the change on the CPV, I'm going to change the color from green to red again, click on save, and look at that, no errors at all, but things are flashing in red, looking good. So look at how much smaller our code is now, and less code often means code that's easier to understand and easier to maintain. Now what we've just done is referred to in programming as refactoring. Refactoring is rewriting computer code for more efficiency, readability, and maintainability without altering the underlying execution results. So what we've done is we've refactored our code by reducing the repeated code through introducing functions. Nice! Now let's learn how to create functions with arguments. When you print, you pass in an argument for whatever it is that you want to print, and when you use the time.sleep function, you pass in an argument for the amount of seconds that you want to pause. Now our code simply displays the default light color, but what if we wanted to modify our code so that we could pass in potentially different colors each time we flashed a dit? Now this isn't a very practical example because for real Morse code, you probably wouldn't want to change your flashing colors, but creating a function that passes a color value is a good chance for us to introduce how to create and use a function with arguments. Now to add an argument in our function, we'll just head up to our function definition and we'll enter the name of the argument between the parentheses. And the name that we use will act as a variable that will hold any value that's passed into the function. And we'll use this argument name in any of the lines of the function below whenever we want to use that value. So in our dit function, I'm going to add an argument named dit_color. Then I'm going to copy this name and I'm going to paste it over light_color that's already inside of the function. This way, whenever we pass a value in, I'll pick up that value in the definition of the function as the variable dit_color, and I'll use that value in this pixel fill statement right here in what is my line 25. So now I've just changed the definition of our dit function. This function now requires an argument. So any function calls that don't pass in an argument to the dit function will generate an error. So I'm going to pass in light_color as my first call to the dit function. And when I run my code, whatever value is inside of light_color is going to be passed into the dit function. That's going to be picked up and saved into this value dit_color. And that's going to be used in this statement where I fill in the colors of my pixels. Now I'm going to show you a very common error that new programmers and seasoned programmers make alike. I'm going to open up the serial monitor, I'm going to save and run my code, and oh, I see the error. And this says in line 38 that the function takes one positional argument, but 0 were given. So if we scroll up and take a look at 38, and oh yeah, I need to change each and every call to the dit function, making sure that I've passed in an argument because the dit function now requires an argument. So for now, I'll just highlight light_color, copy it, and paste it in between the parentheses of any place where I call the dit function. And you know what? Before we save and run, so that I can see that this attribute is working properly, the first time I call dit, I'm going to pass in red, the second time I'm going to pass in green, and the third time I'm going to pass in blue. This is just so that we see some changes in our flashing. I'll open up the serial monitor, I'll click on save, and look at that, the 3 dits and the first letter S show up as red, green, blue. Cool. Now time for your challenge. Modify the DA function to accept an argument named DA_color that you'll use to fill in the color of the lights, and then modify your code so that you pass in green, blue, and red for each of the 3 calls to DA that you use when you flash the letter O. So hopefully you got this. Right in the definition of the DA function, I'm going to add DA_color in between the parentheses. I've just given it an argument. That'll make sure that I pass in this value DA_color in between the parentheses of pixels.fill. And now in the 3 places where I call DA color to create the O, I'm going to pass in green, blue, and red. And I'm going to delete this line in line 50. I didn't need to sleep between dits and DAs because I'm sleeping between letters. Then I'll click save to run this. Again, I should have the serial monitor open, but we can see that things are looking good. Our first dits are red, green, blue, and our dashes are green, blue, red. Now let's take another look at our code. Each call to the dit or DA function is followed by a time.sleep call. And the only thing that's different in these time.sleep calls is the value that's passed into time.sleep. Can we modify our dit and our DA functions to include time sleep and instead pass in a second parameter that we could use as the time to sleep? Why, yes, my friends, we can. Let's give this a try for dit, and then in the challenge you'll do the same for DA. So up here inside of my dit function, I'm going to add a new line right at the end of the function, making sure that it's indented. It'll be time.sleep, and in between the parentheses, well, I need to pass in a value that's going to be my second argument. So I'm going to add a second argument to the function up here right after dit color. I'm going to say comma. I'm going to call the second argument sleep_time. I'm going to copy it, and I'm going to use sleep_time in between the parentheses for my time.sleep. Now let's go down here to our call to dit. We need to add that second parameter in here, so I'm going to put in a comma, and then I'm going to cut out from the time.sleep below this, between _dits _and _DAs. I'm going to paste that in as a second argument for the call, then I can delete time.sleep, and I'm going to go back to flashing my SOS in red. So I'm going to copy my first call to dit. I'm going to paste it over the second 2 lines here for the second dit. But for the third line, I'm going to highlight and copy the parameter that's in between time sleep. That's between _letters _pause. Cut it out, paste it in as a second parameter for the last dit because I'm between letters here. I want to pause. I can delete my time.sleep. And look at this. My S letter is now just 3 lines of code. Cool. Now watch what happens if we open our serial console and we click on save, and oh, we've got another error. Do you remember what's causing this error? Oh yeah, we saw this before. We modified our function so it now has 2 arguments, but we've got 3 different calls to dit that we didn't modify to include that second argument. So let's make that change. And to enter this quickly, what I'm going to do is I'm going to highlight all of the code for S. I'm going to copy that. Then I'll highlight the code for the last S except for the last time sleep line. I'll paste over the code that I just copied. And then I'm going to highlight this value here between words pause, cut that out, paste that in as the second parameter for my last call to dit, and now I can delete the time.sleep at the end. Look at that. Each time I want to show a dit, it's just 1 call to the function. And I already opened the serial console, but you know what? Before I save and run this, I'm going to change the different red and blue and green values in here and go back to passing in the light_color value. Click on save, and things are looking good. Now for the last challenge, no surprise, modify the DA function to accept a second argument sleep_time and change your code so that you call DA, passing in the appropriate value for the second argument, reducing the size of your code. Save your work when you're done. I'm going to save mine as lesson-2-functions, and the solution should be clear to you at this point, so I won't post a solution video, although if you look at the code on my screen right now, that is the solution. But you might also notice when looking at your code that it is possible to write just one function to handle both dits and das, and pass in an additional argument for the dit pause or the da pause. Now, whether or not you want to do this is up to you as the programmer. Code might read a little bit easier if there's a separate dit function and a da function than if you had a single function but with a dit or a da parameter. It's usually better to err on the side of readability than reducing code in ways that make your code less readable. But if you want to experiment with writing a single function with 3 parameters, feel free to do that, and you can save that with yet another file name. Now, do know that while we've introduced the topic of functions, there are some additional important topics in functions that we haven't covered in this video. For example, function return values and function variable scope. But we've got a pretty solid introduction that we can apply in our making projects, and you can look forward to many more new topics in the videos to come. But in this video, Python programmer, we had more big learning. We solved the SOS challenge. We added an intermediate variable to make it easier to update multiple values with a single change. We learned how to use find and replace in Moo. We learned how to implement functions in CircuitPython, one-argument functions, how to spot and correct errors when calling functions without the proper number of arguments, 2-argument functions, and we learned about refactoring when we refactored our code using functions for more efficiency, readability, and maintainability. Hope you're feeling good about your increasing skills, CircuitPython programmer. Keep at it.